All right, we're going to jump into lesson 3.3 for Math 3C, which is on surface area of pyramids and cones. And so we'll start with the formula for the lateral area of a regular pyramid. First, I want to highlight that it says the regular pyramid here, right? So we've got a regular pyramid, and that's important. Remember, we talked about this before, that a regular polygon means that all of the sides are the same length. So if you forgot about that, maybe make a note there, because that's going to come into play. That means all the sides for whatever the shape is are the same length here. So here we go into the formula for the lateral area of a regular pyramid, and it says L for lateral area equals 1/2 P times L, and this is a cursive L here. So we need to know what those variables stand for, and P is going to be the perimeter of the base. So I'll go ahead and write that. So we would have to find that perimeter of the base. Remember, to find the perimeter, you add up all of the sides, and L is the slant height. Okay, and you can see that they've identified L here as the height of this triangle. It's a slant height because it's kind of slanted, since each one of those sides is slanted there. And then P would mean that we would have to add up each one of these four sides of that rectangular base for that rectangular pyramid, all right? And so then to find the surface area, remember surface area is everything, not just the sides. We would just have to find add on the area of the base in this case. So we have the same thing as the lateral area. That's all the sides, basically all the triangles from that pyramid, plus the bottom of the pyramid. And so that's going to be the area of the base, which is what the big B stands for. This is the area of the base. Okay, and that could change. So for this one, right, the one that they're showing you this example of, let me highlight it here, that would be length times width, because it's a rectangle. But notice over here, this pyramid, the base is a triangle because it's a triangular pyramid. So for that base, you'd have to do 1/2 base times height. And we'll talk about that as we get there. All right, it says find the lateral area and the surface area of each regular pyramid. So let's start with the lateral area. We have a formula for it. Lateral area is 1/2 P times L here. And remember, P stands for the perimeter. Remember, this is a regular polygon, so that means that if this side here is 5, then each one of these sides on the base is 5. So I can fill those in if I want, right? Each one of these is going to be 5. And so to find the perimeter, we would add those all up, and there's 4 of them, so 5 plus 5 plus 5 plus 5, and we'd end up with 1/2 times 20 for the perimeter. And then the slant height there, they've identified it as 9. And so then we can go ahead and evaluate here, and that's going to give me a lateral area of 90 square inches. Okay, and now to find the surface area, we're just going to take that 90, right, because that's all the triangles basically, and we're going to add the area of the base. So we have S equals, that's going to be 90, that's the lateral area, plus the big B, which is the area of the base. In this case, it's just going to be length times width, because the base is a rectangle, so that's 5 times 5. And so I end up with 90 plus 25 for a grand total of 115 square inches. All right, we'll keep going. Same idea here, except notice right off the bat that they did not give me the slant height, the cursive L. They gave me the actual height of this pyramid, not the slant height. So I have to find the slant height. So I'm going to kind of zoom into this triangle that they've highlighted for me here, right? So we have this triangle where the hypotenuse is the slant height, right? So I'm going to zoom in here. Got the slant height there. We've got the actual height of the pyramid as 12. And notice it says the whole base is 10, but we only want half of that, right? Because notice it's at the center there of the pyramid. So this is really just 5 for this triangle. And now we can go ahead and use Pythagorean theorem to find the slant height, remembering that 12 squared plus 5 squared equals the hypotenuse squared. And so that's going to give me 144 plus 25 equals L squared. That's 169 equals L squared. So that means that my slant height is 13. Okay, so we got the slant height. Now we can go ahead and find the lateral area here using our formula. L equals 1/2 P times the slant height. So that's going to be 1/2 the perimeter. Each side is 10, so there's 4 of them, right? Because it's a rectangle, so 10 plus 10 plus 10 plus 10 gives me 40. And then the slant height we found to be 13. And then I can go ahead and evaluate that there, and that's going to end up giving me 260. And these are square meters for the lateral area. And now we can go ahead and find the total surface area. And so the surface area is going to be that 260, that's all the triangles, plus the area of the base here. And we know that the base is just a square, a rectangle, 10 times 10, which would be 100. And so we get a grand total of 360 square meters. All right, to letter C here, we can use the same piece. They've given me the slant height this time, so that's nice. So we're going to go ahead and use that formula. L equals 1/2 P times L. And this time it's going to be 1/2. The perimeter in this case is a triangle, right? So notice when I add up the perimeter, I just have to add up 4 3 times because the triangle just has the 3 sides. So that's just going to give me 1/2. The perimeter is going to be 12. And the slant height they've given me as 6. And so I can go ahead and find that this is going to be 36 centimeters squared for my lateral area. Okay, so that's everything except for the base of the triangular pyramid. So we need to know the area of this base, but the problem is that this is not a right triangle. So I don't know the height of that base because I need to know 1/2 base times height for that triangle on the bottom. I'm going to zoom in on that piece right now. So here's that triangle. Okay, and we know that they've given me 4 here, right? I need to know the height of this triangle so that I can find the area of it, right? And to do that, I'm going to have to use a Pythagorean theorem again. I know that if this whole side is 4, then this little piece here has got to be 2. And so the height of this triangle is going to be one of my sides here. So I'm going to use the h squared plus 2 squared equals the hypotenuse squared, which is 4. And so that's going to give me h squared plus 4 equals 16, so I'm going to get h squared equals 12, right? And then I can square root both sides, and I end up with h equals the square root of 12, which is not a perfect square, so I'll leave it as that. And so now I can jump into finding my surface area, which we know is going to be 36, that's from above, the lateral area, plus the area of the base. Remember, this is the big B. And in this case, instead of just doing length times width, because it's not a rectangle anymore, I have to do 1/2 base times height. And we know that the base of this triangle is 4, and we just found the height to be the square root of 12. Okay, and so then we can go ahead and evaluate. That's going to be 36 plus 2 square root of 12. And if I were to evaluate this all the way out, I'd get approximately 42.9 centimeters squared. All right. So real quick, I just want to highlight why I had to do that extra work on these problems over here, right? Notice the base is a rectangle, so that's quick and easy to find the area of, right? Just 5 times 5. But over here, the base is a triangle, so I have to use 1/2 base times height to find the area of a triangle. And so I needed to find the height of that triangle. I didn't know what it was, so I had to do a little extra work there, and then I can find it, and I get my answer. All right, we'll go to the next page here. We'll look at the lateral area of a cone. So we've got some formulas again, right? Again, we're using the cursive L as the slant height and R as the radius. And so that's going to give me the area around the sides. And then to find the surface area, I would just take the area around the sides and add the area of that circle on the bottom. And to find the area of a circle, it's just pi r squared, right? So that's how I would find that. So it says find the lateral area. So we'll go ahead and jump into our formula there. We have L equals pi RL. And that's just going to be pi times the radius, which is 6, times the slant height, which we don't know here. So we're going to have to use some Pythagorean theorem to find it. So I'll go ahead and zoom in up here on that triangle. 6 and 8, and this is going to be L here, so we're going to end up with, let's see, 6 squared plus 8 squared equals L squared, and that's going to give me 100 equals L squared, and L is going to give me 10. Right? I'm going through it quickly, right? You can slow this down, try it on your own. But we're just using Pythagorean theorem again to find what the slant height is there. So then I can tack that into my lateral area formula, and I end up with 60 pi as my lateral area. These are centimeters squared. And now to find the surface area, we're going to take the lateral area, which is 60 pi, and we're going to add the area of the circle, pi r squared. So that's going to be 60 pi plus pi times 6 squared, which is going to give me 60 pi plus 36 pi, and that's 96 pi centimeters squared. And to letter B, same idea, except notice for this one, for letter B, they did not give me the radius this time, right? So I got to find the radius. Let me zoom into that triangle real quick. Looks like this. Or this time we know the hypotenuse is 25. We know my other side length is 24, and we're looking for the radius here. So I would set it up as 24 squared plus r squared equals 25 squared. I go through Pythagorean theorem here. I'm going to end up with r squared equals 49, which means that r equals 7. All right, so I skipped some steps there, but it's just a Pythagorean theorem that we've seen a handful of times now. Okay, and so we get the radius is 7. Now I can jump into my lateral area formula. L equals pi RL. And so that's going to be pi times the radius, which is 7, times the slant height, which they gave me this time as 25. And that's going to give me 175 pi. And that's centimeters squared as the lateral area. And so, of course, that's just the area around the sides. Now to find the surface area, I need to add on the area of that circle there. And so we're going to get S equals 175 pi plus pi r squared, and we know that r is 7. So that's going to be 175 pi plus 49 pi, which gives me 224 pi. And that's centimeters squared. All right, thanks for watching.